already seen, and you've also probably noticed on your bill, is that we now have 1 millisecond billing granularity for Lambda functions. Previously, this was 100 milliseconds. Now you are truly paying for value with Lambda because you pay in 1 millisecond increments. So what does that mean? Well, in the past, if you had like a 25, 26 millisecond duration of your Lambda function, we would round up to 100, and you'd be paying for that time that you really didn't use. Now you would be paying for the 25, 26 milliseconds. The pricing is pretty much the same, but because it's a much smaller granularity, most folks are going to see some savings on their Lambda bill. Short-lived functions are going to have the biggest cost benefit. And you should be seeing this already on your Lambda bill. It was effective in December. As of December 1st, when we announced this, it became live in all of your billing statements. Nothing you need to do. You can call your AWS account rep if you have one and you like them, but there's nothing they can do for you. This was just automatic for everybody. Pretty cool. We also announced during Andy's keynote, I believe, that we now have larger function sizes as well. So a few years ago, we went up to 3 GB of memory or power. Now we're up to 10 GB, which is about a 3x increase, if you will. And with Lambda, CPU, networking are allocated along with that memory or power rating. So when you use a 10 GB function, you actually have 6 virtual CPUs allocated to your function as well. This is really intended for use cases like machine learning, ETL jobs. Maybe you're doing some genomics or HPC, but then you might run into some file system limitations as well. But really, these are bigger functions that are out there if you need them for the right use cases. I always caution customers to make sure you power tune your function before, especially with these larger sizes. There's some nice power tuning projects out there, including one from Alex, one of our developer advocates. You can actually go run your function a number of times at different memory or power ratings and see where you find that right mix between speed and cost, right? Because we always want to make sure we're getting good value out of what we're doing. Also announced at reInvent, but not going to be covered specifically, is that AWS Compute Optimizer now handles Lambda as well. And instead of running your function like Alex's project does, it actually kind of looks at the historical memory utilization for the function and tries to make some recommendations. Which one you want to use is kind of up to you. Your mileage may vary between them. I generally have always recommended the power tuning project in the past. So the announcement that got everybody all hot and bothered, Lambda now supports container images. So what does this really mean? Lambda is not now a container orchestration platform. But what we did is we've added another packaging type. So this makes it a lot easier for you to manage dependencies, to manage larger dependencies, to have larger functions, frankly. And if you're already working in a place that you have a lot of container expertise, you have container tooling, maybe you like using vulnerability scanners and things that kind of live in that world, you can now use that same packaging type and run that containerized function on Lambda. So that's really the benefit here, is the packaging format. Everything else, for the most part, is going to be the same. It's still event-driven. You still have integrations with all of the other AWS services. You still have a handler function or a handler method that you need to deal with. It's just we're packaging it up differently. So historically, since Lambda launched, we used zip file packaging, and that is still all well and good. It is still, nothing has changed in that vein. You can still use a zip file to package up and deploy your function. Now, one thing that is also a little bit different with containers is that the function itself can be much larger now. So with the zip packaging, it can be a maximum of 250 megabytes uncompressed. With the container images, they can actually go up to 10 gigabytes. And that's a different 10 gigabyte than we saw on the previous slide. So if you have really large dependencies, you have ML models that you want to package into your function, maybe you have a data set that you want to include, so that your function can go look something up locally in a local file. Container images are an option now because, again, they can get quite large. What's really impressive, though, is that you still see the same sub-second auto-scaling, very high availability. In the testing that I've seen people do so far, there's really not a big difference in latencies, even with cold starts, between container images and the zip file packaging. And again, the pay model, the billing model is exactly the same here. So in practice, what is the developer experience like with this container, with container images? That is a little bit different. So you're going to define a container image using, kind of the common open container formats that you're used to. There's some specific versions that you need to use, but in truth, it looks a lot like it is a Docker file, right? So you take that container image, you want to build it, and then push it to ECR, which is the Elastic Container Registry. So for that container image as a baseline, the Lambda team has published a set of container base images to both the public ECR, which was also announced at reInvent this year, as well as Docker Hub. So you can go grab that kind of baseline image for any of the runtimes that Lambda supports. You can also build your own image if you'd like to, using something like Alpine or Debian. But as part of building your own container image, you're going to need to include something called the runtime interface client. And basically what the RIC does is it allows the Lambda service to interface with your function and interoperate with it in different ways, including not really just including the handler, but doing some other work with it and kind of managing it like a Lambda function. My recommendation, start with the container images that the Lambda team has provided. They're maybe not super as slim as like what an Alpine image looks like, but they are slim enough. You're not going to have any performance problems, and they're a really good starting point. Now, today, your image does need to live in ECR for Lambda to actually use it. So the built image needs to be in ECR today. So once you've pushed out the image to ECR, you can actually go create the function. When you go to create the function, the Lambda service is going to go pull that image from ECR, and it's going to go through an optimization process. And essentially what we're doing is we're using the fact that container images have layers. And when you have something like a common layer, like one of those base images, we can cache that common layer very, very effectively. So there's actually 2 different cache points in each region where we can cache different layers. And that's part of how they get that awesome performance, even in cold start situations. So when you first go to create the function, it's going to go into a status of pending. And that's a period of time, usually not much more than a couple of minutes, where the Lambda service is taking care of optimizing the image on your behalf. And once that process is finished, the Lambda function becomes active. That's when it can start handling traffic and acting just like any other Lambda function that you've built in the past. There is kind of a, if you haven't touched this image, if it's been, or this function, if it's been, idle for, I don't remember if it's 14 or 30 days right now, your function may go back into a pending state. And then the first time it gets kicked again or invoked again, it's going to go back to active. So you'll see a little bit longer cold start. Just something to bear in mind. So I'm going to pause there for a second because generally this is where people have a few questions. Otherwise, I can throw out a few more tidbits if people want to. Nothing.
Can you use those containers on different providers?
Can you use the containers on different providers? You can. The only thing is you have to have that runtime interface client installed. But I have seen a couple of people in the serverless community going and building containers and then running them elsewhere. What's cool is, in your Docker file, your whatever you want to call it, you can actually define like the entry point or the command that gets run, when that container goes live. But the Lambda function itself can actually override some of that as well. So you can actually package multiple functions in a single container image if you'd like to, and then use the Lambda function configuration to define, what to do when each of those functions is called. That's actually a really good way to kind of reduce the size of what's being stored in ECR or the bandwidth needs, pulling the images out of ECR if you have like a really, really big dependency or a lot of shared stuff that gets pretty large across functions. Other questions? All right, so container image support, it's pretty cool, pretty easy to start working with. If you use AWS SAM, which is the serverless application model, there's also the command line tool. It already has support for building and deploying with this image type. And I have seen like the serverless framework and others have support for this as well. One thing to bear in mind, if you use Lambda layers are not supported with container images today. There is a blog post out there from the developer advocacy team on how to deal with layers if you really need them in this case, but it generally involves kind of going and grabbing the layer zip file, exploding it, and then dumping it into your image. Another new feature or operational capability that we launched is CloudWatch Lambda Insights. So this is a new set of dashboards and kind of pre-built metrics that the CloudWatch team created. So really good at getting you information about a single function or a set of functions like duration, the number of invocations, errors. You'll also see some data in here like maximum memory usage, network usage. Some of that information wasn't available to you even, or it was stored away in CloudWatch log trails. Now they're using the capability that we're going to talk about next, Lambda extensions, to be able to kind of pull some of that data out and give you access to it directly in CloudWatch. This is really easy to enable, at least in the console, right? It's just a little switch that you go flick on for the most part. And there's ways to set this up with CloudFormation and other tools as well. Lambda extensions. So this is a feature that we launched just before reInvent, or pre-invent, if you will. And really the idea behind extensions is to give you, to allow you to have a little bit more insight and control over what's going on in the Lambda lifecycle. So that dreaded cold start we all hear about, when your function gets called for the very first time, we go and create an execution environment, load the runtime, load your function, and then it actually kicks off and starts running. So in the past, you didn't have, you could optimize your function and there were some things that you could do to make that as fast as possible, but you didn't have a whole lot of insight around what was going on around it. So the idea with extensions is that you can register a bit of code with the extension API, which is one of those runtime interface client type of things. And you can essentially have your extension register for a couple of different callbacks. One on initialization, which is basically when that execution environment gets spun up the first time. One on when the function is invoked, and when the execution environment shuts down. Those are the three. And essentially, along with each one of those, you can capture some data from the environment, from the function, and do something with it. So today, we've seen a lot of AWS partners like Lumigo and Dashboard and others who have implemented some interesting monitoring and configuration solutions using extensions. Generally, I'm seeing maybe like a Cloud Center of Excellence at my customers, but more likely some of these enterprise tooling vendors that are taking advantage of this capability because they can get a lot deeper into what's happening with Lambda and what's going on around your function without developers having to bend over backwards trying to insert code all over the place. So very useful. This again is where some of those vendors and where the CloudWatch team is getting information about memory utilization, network utilization, etc. One of the more interesting extensions I've seen so far was built by Stripe. They have a blog post and they have the code out on GitHub if you're interested. But what they do is part of their extension is they actually make a call to AWS Secrets Manager. And based on the function's configuration, they go and retrieve the secret values of whatever secrets they need for that function. And they write those values to a text file in the local storage, the temp directory that Lambda provides. So then when the function is actually invoked, it doesn't have to go talk to the Secrets Manager API anymore. It basically just goes and looks in that temp directory and pulls the secret out of the local file system, which is a lot faster. So pretty cool. A lot of extensions you see, at least so far, have been built in Go, and that's because it can be built into a native executable, so the runtime doesn't matter. You can also build runtime specific extensions, but then your Ruby extension can only work with the Ruby function. There's a couple different types of extensions out there as well, but we won't get into that detail. We'll just kind of stick with where things are at here. So another capability kind of brought along with the extensions API is what we call the logs API. And essentially what this allows you to do is stream your logs directly from your Lambda execution environment off to whatever kind of logging vendor you might be working with. All right. I'll come back to the question that's in the chat in just a second. Yeah, you can send those logs off to whatever partner you might have that has enabled this. So Datadog, Lumigo, New Relic, Sumo Logic have all already integrated with this API. You can also build your own. And the example that we're showing is instead of, we're writing log messages directly to S3. So basically, anytime you write console.log in Node or print in Python, that log's going to usually be shipped off to CloudWatch Logs, and it still will. But now you can write this to another source as well, and you don't need to have like a Kinesis stream or something else going on to write those log files off. If you do want to disable logging to CloudWatch Logs, you can do that using IAM permissions. Another feature that launched just before reInvent is Lambda code signing. So essentially what this allows you to do is to cryptographically sign your Lambda code, your Lambda function. And that gives your security folks some control over what gets deployed to your account or maybe to the production account only if it's been signed. You can also ensure the code hasn't been altered since it was signed. And this uses another tool in the AWS toolbox called the AWS Code Signer. And this isn't all that different, at least conceptually for me, to the way the app stores work. You get a developer certificate and you go and sign your code just to verify that it's you. So this is actually pretty easy to use, pretty easy to go build into, build into like your deployment processes if you'd like to. But pretty easy to get started. I know there's a nice blog post out there on this as well. AVX2 support. So this actually takes advantage of some hardware and some of the chips that are available now. But really, if you have a function that is very, very compute intensive, it's doing a lot of hard work, you might benefit from using AVX2 support. Machine learning inferencing, media processing, etc. Right? We're really just compute heavy functions. So the example that we're showing here is some image processing. And I'm not an expert in image processing or the filters that we've applied here. But what we did was we took an image processing library and applied 3 different filters to that pretty picture at the top. And we did it just kind of normal, and then we ran it with AVX2 enabled. And you can see you get a pretty good performance boost out of using AVX2. In order to use AVX2, you do need to recompile your source code and any dependencies to take advantage of it. But there's nothing you need to do from a Lambda function standpoint. There's no checkbox or anything you need to go enable. If you've enabled it or compiled it into your code properly, it should just run. And there's support for Python, Java, Go, Node, and other runtimes out there as well. Two last things on Lambda, both of which have to do with dealing with streams of data. And these both popped up towards the third week of the first section of reInvent, whatever you want to call it, mostly as blog posts. So this first one is actually something I've been playing with the last day or so in between meetings and stuff. But this allows you to do streaming analytics, from data coming off of Kinesis streams or DynamoDB streams. And essentially what you can do is you can define a time window of up to 15 minutes and have your function kind of maintain state across multiple invocations, right? So, in the little example diagram here, we've got a stream that has these 30-second time windows, and across each invocation, we're kind of passing the previous result so that at the end, you can come up with a sum across these, 4 different invocations of the Lambda function. So it's doing both aggregation as well as, some analysis on the data. Maybe you want to store the data to DynamoDB after each time window, whatever you'd like to do. But what's interesting here is that you have some state in between invokes, which is something you haven't had access to in the past. So this is a really nice lightweight solution for calculating things like count, max, min, averages, etc. in these time windows. You may have used something like Kinesis Data Analytics or Apache Flink to do that in the past. This is a little bit lighter weight solution for solving that. So pretty interesting capability for window or streaming type analytics. All you need to do is go enable a time window for it. You can use SAM or CloudFormation to do that, as well as the console. And you'll actually notice in the event payload that arrives from the stream, there'll be some extra arguments in there, some extra parameters in there that indicate, if this is the last event for that particular time window, whatever it might be, as well as the previous state, I should say. If you happen to watch my talk at 7:30 tonight, it's the rerun, you'll notice that I talk about how to deal with errors when you're doing stream processing. Unfortunately, I didn't get to talk about this. It would have made the talk, it would have added to the talk. But we've added custom checkpoints to to streaming event sources as well. So Kinesis, DynamoDB streams. And as you're probably familiar, when you're processing, data from streaming event sources in Lambda, you get batches of records at a time, right? Maybe in this example, 10. And the default behavior is that the entire batch succeeds or the entire batch fails. So in this case, if we have a bad message or a poison pill in there, like record 7, and we just throw an error or raise an exception, the whole batch is going to fail, and then we're going to retry the entire batch again for as long, essentially, as those messages are on the stream. So there is a feature that's been around for a while called bisect batch on function error, and essentially what that does is if a batch fails, we'll start kind of breaking that batch in half repeatedly until eventually you get down to just the 1 or 2, however many records in that batch are bad or causing an exception. But that generates potentially some unnecessary Lambda invocations, and you end up reprocessing successful messages. So if your function isn't idempotent, that might lead to some side effects that you don't intend for. So with custom checkpoints, essentially what you can do is, again, you enable this in your function configuration, and then as a result of that function, kind of the result that gets returned, you can specify where the failure occurred. And that's what we're showing here is that, 7 is the bad record. So now we've set the checkpoint as being at number 7 so that we're not reprocessing the messages that were successfully processed in the past. So a really nice feature, particularly again for streaming event sources. There's a bunch of other stuff around Lambda, like support for private link. If you want to be able to call the Lambda management API without going out over the internet from your VPC, you can now use private link to do that. We also have some new VPC access controls for IAM that you can take advantage of, as well as a few new event sources for Lambda. So these are, again, built-in event sources where you're not having to have your function poll, whatever this data source is, to check for new data. So those new event sources include Amazon MQ, our Amazon MSK, which is managed streaming Kafka, which is our managed Kafka service. And you can also use your self-hosted Kafka as well as an event source. Again, you have to have some network connectivity and whatnot. And it takes a little bit more to set that up, but you can now use your own Kafka cluster as an event source. The last item on here isn't Lambda specific so much, but we do tend to see people talking about this in the world of Lambda at times. There is a new version, v3, of the AWS SDK for JavaScript, and it's really a lot more modular than the old version was. In the past, you had to include the entire AWS SDK, and if you wanted to do things like tree shaking, you could probably slim down to only the code or only the set of dependencies that you needed. But with v3, things are a lot more modular now. You can just include the services you want, maybe even just like the specific command you want to go execute against. So your code can actually get, or your dependencies can get a lot smaller. So that's Lambda. I can jump into some other services. So the first, let's talk about is Eventbridge. So Eventbridge is a serverless event bus. Pretty cool service if you haven't worked with it in the past. There's some new cross-account capabilities that I'll talk about. But with Eventbridge, it's a nice way to start building an event-driven architecture, which is something that we're seeing a lot of clients do these days. You can reach very, very large scale, have asynchronous processing, build a lot of resiliency into the system. So we're going to talk about archive and replay and resource policies in just a minute. But Eventbridge also recently added dead letter queues, right? So if processing of the message fails, depending on the configuration multiple times, we can go throw that message into a dead letter queue. There's also some new retry policies for Eventbridge that if you've worked with SNS, for example, as an event source for Lambda should feel pretty familiar. And then all messages are also encrypted on the server side now. So two of the bigger announcements with Eventbridge. First, there's now support for archive and replay. So you can now archive events coming off of your event bus to an S3 bucket that's managed by the Eventbridge team. Essentially, you have the ability to pick which event bus you want to use, maybe the default event bus or a custom event bus. And you can use the same exact JSON type of filtering syntax that Eventbridge uses to filter and route messages to specify which ones to archive as well. So maybe you own a pizza shop and you only want to archive, new pizza orders, but nothing where, people cancel the order or maybe, complain about your service. You can specify that in a filtering syntax and only save those away. And once you've archived those messages, you can go back and replay them. And you can get very specific on a time frame. So this is super helpful if you fixed a bug or if you're applying new features and you just want to rerun that past data through whatever processing you have. And again, the messages kind of allow you to compose the state, so you can kind of go replay very, very easily. Resource policies for Eventbridge. This is really a lot meant to help you manage access to the event bus a lot easier than it used to be when you were managing IAM permissions and whatnot. So with these resource policies, you can specify the particular API actions that you want to allow. You can specify other accounts that you want to have access to your event bus. And then particularly in enterprises where you might have a centralized or shared account with a single Eventbridge event bus, or maybe you have multiple event buses flowing around your organization, it makes it a lot easier to manage. I've worked with some customers that use SNS for eventing, for example. And if you want to add a new filter pattern, you need to reach out to the team that owns that SNS topic. By using resource policies with Eventbridge, you can specify, hey, this other team has the ability to go create a new rule on my bus. So the policy we're looking at on the screen is kind of an insurance example. We have an event bus in a shared account called claims. And we're giving some other account called my other account permission to put events on that claims event bus. You can even add conditions around details in the specific event. So in this case, we're specifying the event source, which again is included in that event payload, as well as the detail type. So again, very, very friendly if you're looking to use event-driven architectures to help choreograph how data, how your system works. A couple things on step functions that I'll talk about. We'll talk about synchronous express workflows in a little bit more detail, but step functions added native integrations with Amazon EKS. So essentially what that means, you don't need to go write a Lambda function. You don't need to go write any compute to actually go interact with EKS or with API gateway APIs. Missing a gateway in that second bullet, I'm sorry. So that's really friendly because when you're living kind of the serverless lifestyle, if you will, you'd rather focus on configuration than writing more code. So step functions now has a lot of very easy to use integrations with other AWS services that you can take advantage of. And again, you just configure those directly in your state machine definition, as opposed to having to go write yet another Lambda function just to go call a REST API on API gateway. So synchronous express workflows, this has been a big ask since we introduced express workflows at reInvent 2019. Express workflows, if you're not familiar, these are meant to be very high frequency, fast throughput, workflows, things that take under 5 minutes. Really good example, something like account sign up, right? Where somebody enters their name and whatnot, and you want to go create a new account for them somewhere. Maybe you don't want to build that in a single monolithic Lambda function, but instead you want to use step functions to orchestrate the flow of that process. Well, generally that account signup is probably not going to take more than 5 minutes. So express workflows are a good way to manage that. There's also some cost benefit with using express workflows in some cases. But the way express workflows and step functions generally have worked is that they are asynchronous processing, which means the caller says, hey, go kick off this state machine for me, or this workflow for me, here's the input. And at the end, eventually some point in the future, that process finishes, but it doesn't let the caller know. The caller either needs to poll, or we have to build in some sort of push mechanism to let the caller know. With synchronous express workflows, the caller can basically sit and wait around for that response to come back. So you don't need to write any additional code. This can make things like building a user interface a lot easier, frankly. So again, account signup is a good use case. Sentiment analysis. I've also been working with a customer that does lead capture quite a bit and been working with step functions, and having this synchronous approach made their lives a lot easier. They weren't having to sit there and watch the state of every lead they were creating to wait for it to be complete. And then to finish things up, just kind of a potpourri of other announcements that folks might find interesting. First, AWS X-Ray, which is our distributed tracing tool, now has integration with Amazon S3. So if you've built one of the very, very popular serverless workloads or applications where you go put an image or a file into S3, and then that goes and invokes some Lambda function to do some processing on it, you'll now actually see that S3 bucket as part of your X-ray trace. SNS also added some new features. First is FIFO topics. So if you need guaranteed ordering and only once processing, FIFO topics might be a good fit for your workload. Essentially, the FIFO topic publishes to a FIFO SQS queue, and then your function or whatever can go do processing on that. Just yesterday or today, I can't keep my days straight anymore, SNS added integration with Kinesis Data Firehose as an integration endpoint. So if you want to archive messages coming off of SNS, or you want to use them to feed a dashboard somewhere to do some analysis, you can basically connect SNS to Firehose and stream the data to something like S3 or Elasticsearch, whatever Firehose target you want. You can even hook a Lambda function in there to do some transformation as part of the data movement, so that if there's PII or other information that you don't want to end up in wherever Firehose is delivering, you can do that as well. SQS added a batch window. So in the past, SQS kind of used either the number of messages or kind of the size of the payloads to determine when to go invoke your Lambda function. Now with the batch window, which can be up to 5 minutes, if you have a queue that's maybe not getting as many messages and you want to limit the number of times your Lambda function gets invoked to process only one message, you can use the batch window, and it'll only go invoke the function to do that processing when you kind of reach that time window. Amazon MQ added support for RabbitMQ, so it's another broker in addition to ActiveMQ where we're managing it for you, and you basically just go use RabbitMQ like you normally would. And we also added Amazon managed workflows for Apache Airflow. If you're an Airflow user, right, you don't have to manage it your own, either on-prem or on EC2 anymore. This is a managed service, kind of like MSK in a lot of ways, where we're managing Airflow on your behalf. As Margaret said, reInvent is still going on. We still have tonight and tomorrow. As she mentioned, I have a replay of my session, Handling Errors in a Serverless World, tonight at 7:30. Excellent viewing. My kids loved it today. They came in and watched for a few seconds. Oh, Dad, you're on the computer, and then they bolted. Margaret also has a session herself tomorrow at 11:30, all Central Time, how robots can help make your AWS accounts more secure. And if you don't want to write down these links, it's pretty easy in the search in the upper right-hand corner to go search for a name or a title. And if you're interested in another more official recap than what I just gave you, Chris Munns, who runs our serverless developer advocacy team, also had one that was went live yesterday. That's already available video on demand that you can go watch as well. He goes into some more detail on some of the things that I kind of skimmed over and vice versa. So with that, we can take some more questions if folks are interested. I see there's a question in the chat. I also want to point out serverlessland.com, where you can find all sorts of serverless resources, including some resources relevant to the various serverless talks we've had at reInvent. So I see a question from Helen in the chat. We're using both Lambda and SQS for deployment. Can you talk about pros and cons for both? Could you give me a little bit more detail about what you're looking for there? Like how are you using SQS for deployment?
So, yes, sorry.
It's okay.
You don't have to type it if you just want to talk through it, Helen.
easier to talk rather than typing.
Yeah.
So I work
It's
on
okay.
data science, and we provide AI solutions. Our deployment team, they use both Lambda to deploy that in AWS. So I have seen their demonstration, and another team use SQS for just as what you talked for some batch deployment. But sometimes it seems that Lambda gives us faster and also more cost-efficient solutions. I'm not quite sure, because you are professional in AWS. Can you talk both advantage and disadvantages for both approaches?
I'm trying to understand what you mean by deployment here. Are you,
Mhm.
are they deploying like data? Or
They deploy the deep learning solutions. You may consider that more like a SageMaker solution.
okay, so SQS is a messaging queue.
Yeah, it's like a Kafka, right?
Yeah, I mean, there's some similarities.
Mhm.
So I'm not sure how they're using it for deployment. Or are they just using it to feed data into something?
I'm not quite sure. It's another team's work.
Okay, so I mean, they're very different services. It's hard for me to compare without understanding a little bit more. I mean,
Mhm.
Lambda is serverless compute, right? Where you can go run code and we're managing, the servers and whatnot for you.
Mhm.
SQS again is a queuing service, so you can basically go put messages on SQS, and then something else needs to go process them. Maybe Lambda, maybe something else.
Yeah, sorry, Margaret, and can I have a quick follow-up question?
Yeah, go for it.
Because we only have like 24 people, right? So I can still
Yeah.
have time.
Small
And for
crowd.
SQS, sometimes it's easier to get a bug, right? Because our team has a lot of tech support for them. They may think sometimes it's like a out of memory bug, and they try to use that like a CloudWatch to see where the bug comes from and to see some log files. But CloudWatch takes, we need another license. Do we need to pay for that?
I
No.
mean, everything in I mean, we don't restrict access to anything in your AWS account, but you pay for what you're using.
Gotcha. Okay, thank you.
So yeah, I mean, yeah, I would have to understand a little bit more about what you're trying to tackle. If you have a solution, AWS solution architect, or you work with a partner, this might be a good question for them to dig into as well. Sometimes it's hard for me just in a, dropping in a moment's notice to try to figure out what.
Yeah, surely. Unless we see the log files, yeah. We can also contact the AWS tech support to help us debug. Thank you.
Yeah, if you have a ticket. Yeah, sorry, I don't have a better answer than that. But
Sure.
yeah, I mean, they are very different things. I mean, they work together, and there can be some differences in terms of like how quickly the Lambda function gets invoked. But I'm not sure quite where they're fitting into your deployment strategy.
Gotcha. Thank you.
Other questions? Other things you'd like to hear about? Boy, I must be more clear than I think I am as I'm talking. It's sad everybody's into their second beer and third slice of pizza. All right, well, if there's no other questions, I dropped the links to the various talks that I mentioned at reInvent in the chat that you can grab. And then any other sessions that you catch on the calendar for reInvent, they're making available for video on demand. It looks like the next day this week. And you can also find slide decks for all of these things in the attachments section if you haven't found that yet. So thanks for taking the time tonight. Again, if you have any questions, please feel free to reach out to me. You can also find me on Twitter, and happy to help.